All right, guys, today we're starting on page 13 for your day 4 notes. We're going to talk about a 5-number summary and a box plot today, and they really go together. So a box plot is just a visual representation of your 5-number summary. So first, it gives us the definition of a box and whisker. We use this because it shows us where most of our data lives, and then if we have any outliers, and we make this box and whisker by identifying different quartiles. So the median of your data right here, 5-number summary, you have your minimum is your first number, your maximum is your last number. Your median you already know how to find, that's quartile 2. Quartile 1 is the middle of the first half of data. Quartile 3 is the middle of the second half of your data. Okay, so we'll find these 5 numbers and then we'll turn them into box plots. So first we're going to look at some examples where the box and whiskers are already made for us. So here it says example 1, the box and whisker plot below represents the lengths in seconds of the songs played by a rock band at a concert. Okay, so this first one right here, this is our minimum. This is quartile 1, quartile 2, quartile 3, and our maximum. Okay, that's how a box plot is laid out. So let's find and interpret the range. So range, remember, is maximum minus minimum. So in this case, we would have 300 minus 160, which gives us 140 seconds. Then it says describe the distribution of the data. So remember, our choices are symmetrical or skewed. And then that would be left or right. In this case, we're not symmetrical. Our whiskers are definitely not the same length. Our box doesn't have the median right in the middle, so it's not symmetrical. This would be left skewed because the tail of our data, the longer tail, is on the left. Okay, so for our answer here, we have left skewed. Find and interpret the interquartile range of the data. And this is our more accurate range we like to look at. So we'll take quartile 3, which is 280, minus 220 equals 60 seconds, okay? And majority of our data lives in here, over half of it. So the range, if we exclude any outliers in our data, really is closer to 60 seconds than it is to 140 seconds. Are the data values more spread out below quartile 1 or above quartile 3? So that's where we're looking at our whiskers here. It looks like our left whisker is longer than our right whisker, so we would say below quartile 1. All right, so that's it for this page. If you turn, shapes of box and whiskers. So we talked about this a little bit. Symmetric means that your whiskers have to be the same length. Your median's right in the middle. Skewed left means you have a longer left whisker, more data on the left. Skewed right means you have a longer right whisker, more skewed on the right. So this one says the double box and whisker plot represents the battery lives and hours of 2 brands of cell phones. So brand A and brand B. Okay. Identify the shape and distribution of each. So if we're looking at A, it looks like our whiskers are about the same. Our median's almost right in the middle. So I'm going to go ahead and say that this is roughly symmetric. It is not perfectly symmetrical, but it's pretty close. So I'm going to say that A is symmetric. Brand B here, I would say our right whisker is slightly longer and our median is definitely over here on the left. So this we're going to say is right skewed. Okay. So you're saying what side has more outliers essentially. There's more data on this side that's different or more spread out than on the left. Compare the IQRs of the 2 data sets. So IQR is quartile 3 minus quartile 1. So for A, quartile 3 I would say is right at 4.5 here. 4.5 minus, or actually 4.75 because this tick mark is 4.5. 4.75 and then this one is right on 3.5. minus 3.5. So that would be 1 and 2500. Okay, and this, we're talking about hours, so I'm going to go ahead and label it hours. B, it looks like we have 4.25 minus 3.25, which is just 1 hour difference, okay? So the interquartile range for B is smaller than it is for A. Which brand do you think has a greater standard deviation? And remember, standard deviation is how spread out our data is, how far each point on average is from the mean. So really, we just need to look at our plots overall. Brand A is a much bigger, longer box plot than brand B, so it's going to have a larger standard deviation. So brand A, you need a cell phone that has a battery life more than 3.5 hours most of the time. Which brand should you buy? So 3.5 is here. So it looks like really most of the time both would give you more battery life, but brand A is going to be a much safer choice because the entire box plot is to the right of that, where brand B still has quite a bit of data below that. So we're going to say we want to buy brand A again. All right, last page for today. We're going to talk about how you can take a list of data and actually make the box plot yourself instead of just analyzing it. So first thing we have to do always on these is put our data in order. And I highly suggest you cross things off as you go. It helps you keep track. So here, looks like 3's our smallest, and then we have several 4's. So cross off my 4's. Then we have 7, 11, and 12. Oh, but see, I skipped 10, so I have to put a 10 in here. 10, 11, and 12. Then 14, 16, 17, and 18. Okay, so we need to find our median first. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data, which means the middle is right in between 6 and 7. So 1, 2, 3, 4, 5, 6. This is the middle because I have 6 on this side and I have 6 on this side. Okay, when you have an even number, it's going to be in between two numbers instead of just one. So in between 10 and 11 is 10.5. Okay, quartile 1 means we're going to find the middle of this half. So since there's 6 total, our middle is in between 3 and 4 because now we have 3 and 3. We're dividing it into fourths essentially. Here we have 3 and 3 again. So our quartile 1 is going to be 4. Our quartile 3 would be 15 because that's right in between 14 and 16. Our minimum is 3. Our maximum is 18. Our IQR, in this case, would be 15 minus 4, which is 11. Okay? Now we're going to graph it on our number line here. So I'm going to go ahead and add in tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that just helps sometimes. So 4, well here, our minimum is 3. That's going to be a whisker. Then we have a part of our box to be 4, 10.5, and 15. And our other whisker will be 18. So then I'm just going to turn these into a box. And then these two are your whiskers. Okay, so that's what this one would look like. It says the results below show how many pairs of shoes 35 men and 40 women own. So describe the center and spread of each distribution. So this one, I'm going to go ahead and type so you can see it a little bit easier. Let's do something smaller. Okay, so for our women. The center means we really want to talk about the median. So the median is 14, pairs of shoes. Okay, because that's where our center line is here, 14 pairs of shoes. Then it says the spread, the variation of each distribution, we'll put IQR because that's the more accurate one. We have 17 minus 12 would be 5 pairs. And then the range overall, where we have 24 minus 5 is 19 pairs. Okay, so that's for women. Now we're going to do the same thing for men. The median for men is 7 pairs, it looks like. Our RQR, so the range of our box here is 10 minus 5 is 5 pairs. And then the range, 17 minus 2 is 15 pairs. Then it says compare the number of pairs of shoes owned by men to the number of pairs of shoes owned by women. And really overall here, we're just talking about the general pattern. Women typically own more pairs of shoes than men, is what our picture is telling us overall, especially if we compare these two medians. One of the sets is a standard deviation of 3, and the other one is 4. Which one belongs to the women? Again, you're looking for a higher standard deviation would be your longer plot overall. Or if you look at your range, like here our range for our women is 19, our range for our men is only 15, so we would expect the women to have a higher standard deviation. So we would say 4 because it has a larger range. Okay, so that means our men are our standard deviation of 3. It says, using what you know about standard deviation, about how many women surveyed would you expect to own between 10 and 18 pairs? So you have to remember our median. What was our median? Our median is 14 pairs. And then our standard deviation, we just found out from the question above, is 4 pairs. So really what I'm going to do here is explain to you a little bit of how this works. So if you have a bell curve where your median's right in the middle, one standard deviation away would be, well here, let's go ahead and add 2 marks, 12, 10, 8, 6, 4, 2, 0. And then we'll go up the same amount. So 16, 18, 20, 22, 24, 26 about. One standard deviation away, which would be right here at 10 and then here at 18, which is what our question is asking us about. One standard deviation away in a bell curve, and this is what I mean by a bell curve, where it's symmetric. One standard deviation away, it's going to be 68% of our data. Okay? 2, so this is 1 standard deviation. 2 standard deviations away, which would be 4 more. So then we go to 6 and 22 here. This is going to be where 95% of our data lives. Okay, and then 3 standard deviations away. So here I'm at 6. If I go down to 2 and then up to 26, that's where 99.7 of our data will live. So you'll figure out exactly why this works in calculus, which would be, for most of you, your junior or senior year of high school. But for now, we're just calling it the 68, 95, 99.7 rule. Okay, and what that means is all 68% of our data is 1 standard deviation away. 95% is within 2 standard deviations, and 99.7% is within 3 standard deviations of the median. Okay, so when it says, using what you know about standard deviation, about how many women surveyed would you expect to own between 10 and 18 pairs? Since it's in that first standard deviation, we would expect 68%. Okay, and we get that from this rule or this theorem. Okay, so that's it for today. You are working on pages 16 and 17 for your homework.